Welcome back. So in previous sessions we have seen two different representations of architecture body, that is data flow style and structural. Now in this session I would like to introduce the another way of representation, that is behavioral representation. But in the behavioral representation the concurrent statement is process. So first of all, let us see the syntax for the process. After that, we will see how to write the behavioral architectural model for a given digital circuit. Now coming to syntax of process, its syntax is similar to the syntax of architecture. That means it also has two parts. One is the declarative part and another one is statement part. Of course, here also these two parts separated by the word begin. Okay, so let us see from the beginning. So for the process there is a label name. Okay, process label. Here it is process label colon, but it is optional one. Okay, it is a optional one. Since it is placed in square bracket means that is optional, it is not compulsory. Okay, suppose if you want to use label process with label name, then process label name colon, like that you need to proceed. Otherwise just process of sensitivity list, that means on which inputs the process will be executed, or on which or to which signals it is sensitive, that is it will be executed. Means that process list also optional one, whether you can include or not. Then after process word, the next part I said declarative part. So in the declarations, different types of declarations we can place. Those are type declarations, variable declarations, signal declarations, constant declarations, function definitions, procedure definitions, etc. So these are the different types of declarations you can declare in the declarative part of the process. But if you observe here, there is no component declaration, right? In architecture body we observed that component declaration is there, but not here. Okay, only certain type of declarations only we can do in the process. Those are type, variable, signal, constant, function, procedure. But in the architecture body there is no variable declaration. Here we have that one. So certain declarations only you can declare in the process, but certain only in the architecture. So which that you have to remember. Okay. Then after declarations the syntax is begin. But after begin actually the statements will starts. Here in the process all the statements are referred as the sequential statements. That means their execution is one after another. But in the architecture body the statements are referred as the concurrent statements. Why? Because their execution is simultaneous execution. That is the meaning. Okay, but what are the different types of sequential statements we can use? Are variable assignment statement, signal assignment statement, wait statement, if statement, case statement. So like that the different sequentially executed statements we have, those we can use while writing the programs. Finally end process. Finally the statement is okay. Some more also listed here: loop statement, null statement, exit statement, next statement, procedure call, return statements, and finally end process. End process optional one is label label name of the process. Okay, so like that you can see the syntax for the process. Okay, now coming to maybe with the example. Okay, also given the syntax for the if statement. Why? Because whatever the example we are going to take for writing the behavioral representation, there we are using the if statement, if sequential statement. So that for if also I have given the syntax here. So what is the generally the if statement can be represented in three ways. That is, you can write in three ways. This is the one of the syntax, that is if Boolean expression, then sequential statements and if. That is, in the Boolean expression case, we have the comparison type statement. If the comparison is true, then only it executes the following sequential statements, then end if. Okay. The another type of representation is like this, including the else part. Okay. If the condition is satisfied, it executes certain sequential statements, that is the statements before the word else. If it is false, it executes the statements which are represented after else. Okay, then end if. This is where these two are well known in any other computer related languages. If you know, there also you can identify the if statement, their syntax and usage. And third form of if statement is like this: if Boolean expression, then sequential statements, else if. That is nested if. This is called the nested if statement. Within the if, you can use one more if statement. Such a if statements is referred as nested if statements. Okay. So here again in the nested if case, you have the two models. One is the ELSIF and another one is ELSEIF. Usually in any other languages, you can see the nested if as ELSEIF, including the ELSEIF. But here you can have two types, ELSEIF and ELSIF, like this. Okay. So the difference is, in case of ELSEIF, the number of end if statements are equal to the number of if statements. But ELSIF case, only one end if is enough for all the if statements. Okay. So this is the syntax, already you know. Now I am going to explain one behavioral model for a given logic diagram. So usually when you prefer this type of representation is, that is behavioral representation is, if the available data is a truth table data, a digital circuit, if the data is in the form of truth table, okay, in the form of truth table. So see here, one truth table is there. That truth table represents the the operation of half adder, because two inputs it has and two outputs, two inputs A and B, two outputs are sum and carry. Okay, for the combination of 0 0 at the input, sum and carry results are 0 0. For 0 1 case, sum is 1, carry is 0. For 1 0 case, sum is 1, carry is 0. But when both the inputs are equal to 1, the sum value is 0 but carry is 1. So this truth table data is enough for writing the behavioral model of representation for the architecture. Okay. Now coming to following the syntax, how to represent the architecture in the behavioral model is, as usual, you know, as per syntax, the architecture body starts with architecture, the word architecture, and followed by architecture name of entity name is. Architecture name, entity name, both are the user defined words. That is, user can use his interested names, but usually the name should be proper. That means it is related to the digital system for which we are going to write the program. So here I am placing BEH, that means behavioral, of half adder. Half adder is the entity name already given in the entity declaration part. So the same name I am using here also. Then here no declarations here also, that's why directly I am using the word begin, architecture begin. Then after begin, the statement part starts actually. You know, in the architecture body, the statements are considered as concurrent statements. Here what type of concurrent statement is used in the behavioral model is, that is process. Okay. So process syntax is, it start with the word process followed by sensitivity list. That is, here I am including in the sensitivity list both inputs A and B. So process of A comma B. Then process begin, because within the process also no declarations, that's why directly I am writing begin. After begin, the sequential statements. So which sequential statements I have chosen here as if. Okay, that too nested if I am using, because many conditions are there. If A, B are 0, 0, the expected output is 0, 0. If it is 0, 1, output is 1, 0. If it is 1, 0, output is 1, 0. If it is 0, 1, 1, output is 0. Okay, so nested if I am choosing here. So first of all, if A is 0 and B is 0, first condition I am verifying. If A is 0, B is 0, that means both inputs are 0. Then what is the expected output? Sum is 0, carry also 0. So if this condition is true, I am introducing or I am including the signal assignment statements for sum and carry. That is, sum equal to 0 and carry equal to 0. Both outputs are equal to zeros. Suppose this condition is failed. The execution goes to the else part. In else part, I am going to check one more condition, that is ELS IF. I am now checking the second condition. Now A is 0, B is 1. If this condition is satisfied, the expected output is sum is 1, carry is 0, right? As per the truth table I am writing here, sum is 1, carry is 0. Suppose this condition also failed, then I am going to check the third condition, that is A is 1, B is 0, isn't it? Third condition is, as per the truth table I am writing, A is 1, B is 0. Suppose if this condition is satisfied, that means what? The expected outputs sum equal to 1, carry is 0. Then this is also failed. All these three conditions failed. Then again it goes to the else part. In else part, I included another condition, that is both A equal to 1, B also 1. Then the expected values are the expected outputs, sum is 0, carry is 1. Okay, and if further there is no conditions, 4 conditions over. First condition 0, 0, next 0, 1, 1, 0, 1, 1. All conditions are included. Then end if, finally use end if, that is the closing statement for the if statement. Then end process. End process not written here. End process you have to write after end if. You need to end the process statement. Then end the architecture. End the architecture with their names. Okay, so before end behavioral, you need to enter end process and process test. Okay, so like that you can develop the behavioral style of representation for the digital circuit. So this style is usually preferred when truth table information is available. Okay, right? So you can develop you develop for some other digital systems. If you have any doubts, you can discuss in the next class. Otherwise, we will move to the next part, our next topic maybe. Okay, thank you.